All right, everyone, let's look at Unit 0, Day 5 and 6. And Unit 0, Day 5 and 6 is a little different than what we've done up to this point. I have the notes that you guys are following and filling out in front of me, so I'm going to try to go in the order that the notes go in. But I do want to begin by one thing. You start with a Venn diagram on your notes about the students that are in a foreign language, students that participate in sports. The 23 and the 10 represent only the students that are in foreign language only. The sport 10 would be the kids that are only in sports. The 14 are kids that you can guess that are in foreign language and sports. And then the 3 are those kids that do not participate in either a foreign language or a sport. So in answering the questions 1, 2, 3, 4, and 5, you should be able to work your way down through using these numbers or some combination of those numbers. With that in mind, I also wanted to show you that since we're studying in this particular video two-way tables and relative frequencies, that a Venn diagram, which you've seen and hopefully understand, and a two-way table, it's two ways because we have information that goes left and right. That's one way, that's kind of like a one-way table. And information that goes up and down, that would be another one-way table. And again, put those together and you get a two-way table. This and this give you the same information. Play a sport and take a foreign language, there's 14, and that's the overlap. Do not play a sport, but take a foreign language. Let's see, do not play a sport, take a foreign language, there's your 23. Play a sport, but not a foreign language, there's the 10. And do not play a sport and do not take a foreign language, there's the 3. And then you can imagine that there's totals for each one. For example, in the foreign language circle, there are 23 plus 14 or 37 students or kids that take a foreign language. And there is the 23 plus 14 students that take a foreign language, there's your 37. And so on and so on and so on. And it also makes sense that if we add the total number of students, all four numbers, we end up with a total, I'll call it a total. It's like your overall of 50 students or 50 people that participated in the survey or that gave information or that are part of this Venn diagram. So a two-way table is simply a representation of a Venn diagram, something you've seen before. Now, when we get into trying to fill out some two-way tables, there's an example that comes up in your notes related to males versus females and after-school activities, yeses or nos. Now, in a moment, I'm going to have you pause the video and complete that table, but just to make sure that you know how, I have a sample. The question is, do you like sushi? There's yeses and nos. And what's your favorite sport? And I only gave two choices, so everybody that voted would vote soccer or lacrosse. And I understand that that might not be your favorite, but that's what this table is made up of. Things that I observe right off the bat. There are 25 total people that like soccer. There are 45 total people that like sushi. There are 16 people that do not like sushi but like lacrosse. And there are 80 students that participated in the survey. So I have those marked in black, similar to what you'll see in your notes. And I'm going to reverse engineer these other numbers. For example, I know that if I have 80 students total that took the survey and 25 of them like soccer, then I can do 80 minus 25. And I can get, borrowed from there, make this a 10, and I get 55 students that like lacrosse. Now I'm going to do a little more. Same idea this way. 45 plus something is supposed to equal 80. So once again, 80 minus 45, borrow from the 8, carry the 10. This is a 35. So 35 students do not like sushi. I'm starting to fill in my table. Same idea, let's go on this column right here. Something and 16 make 35. So the 35 minus 16, I need to borrow in this case again. This is a 9, this is a 1. So 19 students do not like sushi but happen to play soccer or like soccer. Let's go with a row, same concept. Something plus 19 equals 25. So 25 minus 19 equals our number. Once again, we'll borrow. This is a 6, and 1 minus 1 is 0. So 6 students like sushi and like soccer. And now we could go a variety. We could tangle with this cell a number of ways. We could do 55 minus 16 to get it here. We could do 45 minus 6, and that is in fact the way we're going to do it because that sounds kind of easy. 45 minus 6 is just 39. So now I have my entire two-way table filled in. I'd like you to pause the video right now to complete your notes on the after-school activity chart, and then you should move on to the next page. Now, if you've paused and you're back, you should be good to go. The next section is on relative frequency. Now, relative frequency is quite simply a division problem. What you're going to do is you're going to establish a probability or a relative frequency for each of those cells occurring. Now, I know that in your chart, you have a caramel versus no caramel, chocolate versus no chocolate chart. You should be able to calculate the totals pretty quickly. And then below that, it shows you a sample. And by the way, pause anytime you need to keep up with and fill in those tables. And then the next piece that I'm looking at, I'm going to show it to you here on the video. I hope this is centered, is this piece right here, where you should have just added 6 and 12, for example, to come up with a total. Same with the 4 and the 3. And then you add your columns up. And then this will be the combination of the totals for the total, as I call it. Now, when you get to relative frequencies, what you'll notice is it's going to matter whether they're asking for a row or a column or the total. Those are your three choices. In the first example that we have here, it talks about the frequencies of the row. So watch what we do. We notice that 6 plus 12 was 18, so the row's total was 18. So look what each of these was done. 6 divided by 18 will give you a percentage. And 12 divided by 18 will give you a percentage. Now, the percentage is given as a decimal in this particular case, but because this is specifically asking for the row, that's what's key here. Whoops. Because it's asking for the row, you have to go ahead and divide your row. So it's 6 divided by, this would have been 18. 6 divided by 18. 4 divided by 7, and so on. That's how you come up with all of these numbers. And then for the bottom piece, it is the total divided by your total. So 10 divided by 25 and 15 divided by 25. And you'll come out with decimals. Each of the columns will have decimal places in all three spaces. And at the far right-hand side, because you're dividing by your row, which is the far right-hand side number, you're going to have 1, 1, and 1. Now, I have it summarized here. If you're looking for a relative frequency, you are going to divide. Very simply, you divide how often an event occurs by the total number of events. That will produce a decimal called a relative frequency. That gives you a relative likelihood that something will occur. A 0.4 relative frequency, if multiplied by 100, for example, would be a 40% relative frequency. So you might see weather forecasts given as percentages, like there's a 40% chance of rain. If we back that out, we could say it's a 0.4 chance of rain. That's what a relative frequency is. That's how often or how likely an event is to occur. Now, as I move on down my set of notes, I see that I get deeper into the caramel, no caramel, chocolate versus no chocolate piece. What I would want you to notice right here is the next section talks about columns. If we're dealing in columns, then you're going to have to go ahead and divide the individual cell by the total of the column. So for example, and then I'm going to ask you to pause once again and fill in this chart. I'm going to zoom way in if I can. I know that my column total, 6 plus 4 is 10. So I'm going to take 6 divided by 10. And 6 divided by 10, if I need a calculator, by all means, I can use it. 6 divided by 10 is 0.6. So I'm going to go ahead and 0.6. Sometimes you put a second decimal place on there. It doesn't really matter. It's okay. You could imagine now we're going to do 4 divided by 10. We're always using this column total. 4 divided by 10, you can guess, is 0.40. And 10 divided by 10 is 1.00. Now, I would encourage you right now to go ahead and pause the video. What I'm looking for right here is that you fill in the correct number in each of the spaces in the first chart. And then the answers, actually, I wrote them on top. I could have written them down below. And hopefully I'm not off the video screen here. You'll notice that I'm going to write your relative frequencies in the relative frequency chart that's below. All right, I'd like you to pause and go ahead and complete that next table. And then finally, if you've paused and you've come back, there's ready for one more slide. There is a slide about the activity of males and females, whether they are jogging, flying kites, or having a picnic. Now, that is a start to finish sort of task. What I would want you to do with this one, of course, is use the skills we started with in the beginning to calculate the actual number of people that would be in each cell. You notice that the total number of people that were surveyed were 50. You also notice that this is slightly different. It says complete the relative frequency table below based on, now here's the third option. Notice that this does not say based on row or column. It says based on total participants. I will remind you that whatever it's based upon, whether it's your row, your column, or your total, that is what you're ultimately going to divide by. So in this example, you're going to divide each of these cells, the 9, the 11, the 4, the 1, the 10, you're going to have to figure this one out. You're going to divide each of those cells and all of the totals by 50. You're going to divide each one of those by 50 because that is what the total number of participants is. I'll do one for you. The jogging piece would be 9 divided by 50. I'm going to grab the calculator. 9 divided by 50 is 0.18. So I'm going to go ahead and put in here 0.18. And that's how I'm going to fill in my relative frequency for all 50 people because I'm going to divide each cell by 50. Now you can pause or you can just finish the video out. The final piece that I want you to do is underneath each of these tabs, oftentimes it says what can be concluded from the relative frequency table. In my opinion, you can make conclusions based on whatever the premise is. And I'll use this layout, which you've seen already once, as my example. I notice as I look across, the 1 shows up on the right-hand side, which means that 1 is the sum of these two numbers. That means that we are doing a relative frequency table by row because this is where the 100% or the full 1 value comes from. Here's what I think that means. I can look at this and say, of the people that like caramel, right, 100% of the people, of the people that like caramel, most of them do not like chocolate. That would be my conclusion. So if I meet somebody on the street and for whatever reason I ask them, do you like caramel? And they say yes, they would be in this row. And then without asking them, I could make an educated guess that says they probably don't like chocolate because more people don't like chocolate in the caramel row than do like chocolate. Now they might surprise me, but they probably won't. Same deal here. If I find someone that does not like caramel and I try to make a judgment on would they like a chocolate chip cookie or not a chocolate chip cookie, I'm going to say if they don't like caramel, these two numbers, this is the greater number. So no caramel means they more likely prefer chocolate than to avoid it. Do you see how that works? And these two numbers down here only simply tell me that if I can look at this, there's more people that prefer, well, avoiding